it is derivative, still derivative. Yeah.
Yeah. Can we do something with that? Let's go back down. I love life. Yeah.
Okay, so we're going to spend a day and we're going to kind of get some terminology straight here because it really helps to get all this stuff right before you jump into the stuff we talked about in chapter 3. So f is some function. Let's let f be defined on some interval I. So what do you think that means? Interval I.
I don't know, but really,
Imaginary.
are you recording it for the swims?
I am.
Swimmers?
I am. Yes, I am. For the swims? Yes, I am.
Okay,
This, okay, what do you think some interval I means? What do you think? Right.
Just like any place between like 2 points.
Okay, yeah, between some values of x maybe, right? So we're gonna pick some interval, some set of x values, and on that span of x values, the function is defined. It doesn't do anything weird, right? Yep.
What does that say after
Containing c.
Oh.
So c is going to be some, and so what c is then? C is a value of.
Constant?
Well, I mean, c a lot of times stands for constant. Just some value of x in this case, right? So what we've got then.
I is
So we've got something like this. Let's say that this interval. Listen, please. Let's
Can you
just.
just say real fast what I is again?
So I is just some range of x values, right? So we're going to say it's going to go from x1 up to, we're going to call it x2, how about? And somewhere on that is going to be some point c, okay? So here's our function. There's our function. Okay, so if we want to only focus on the part of our function that is contained on the closed interval, that means it's going to include the endpoints, right? On the closed interval from x sub 1 up to x sub 2, what I want to do is I want to define an extremum. Okay, let's talk about, here's our vocabulary words here that we're going to be talking about. Extremum, so this is singular. Plural of that would be extrema. What is an extremum?
We're not sure.
Really?
The highest point.
Okay, it could be the highest point. It could also be the
Lowest.
lowest point. So in other words, it's an extreme value, right?
An extreme.
Okay, extreme value would be, either the biggest or the smallest, the most extreme on the interval, okay? Well, what would we call the highest point? What kind of, we can break up an extremum.
An extreme and a maximum.
An extremum could be a
Maximum.
maximum. It could also be a minimum. What would the plural for maximum be?
Maxima.
Yeah,
Maximize.
maxima. How about for minimum?
Minimi.
Minimum. Okay, good. So if we want to, let's focus initially here, let's talk about a maximum. Okay. What do you think we have to come up with some tightly wound mathematical definition here for a maximum. What do you think, how could we say a maximum in a way that's going to be bulletproof, mathematically speaking? Okay, good. So we could say, let's say that it occurs at the x value c. So here is c, and there's the point with coordinates c, f of c, right? So then if we wanted to say that this point is a maximum, then we could say that f of c is what?
Minimum.
Think about that for a second.
Wait, pose the question one more time.
Okay, so we want to write that. We want to figure out what a maximum would be.
Okay.
So if this is a maximum, f of c would have to be what on this interval?
It's in the middle.
Well, maybe
It's the highest.
highest point. But how do we say that? We have a maximum at c, f of c at that point. If what? F of c is what? What does it have to be? You said it's not biggest, right? Say that mathematically.
It's greater.
Oh, okay, greater than
Everything.
or equal to, it could be. Turns out, right?
Yeah.
Greater than or equal to what?
The biggest y value.
Okay, how do we say a y value though for
Why
a function?
not? Wait, you can say greater than or I.
So here's the function y equals f of x, right?
F of X over Y. Y of X.
Okay, let me restate what you've given me so far, right?
Okay, do it.
You've told me that this is a maximum if it's the greatest value of the function, right? That implies y value, but if we're talking about a function, we would call the y value f of x, right? So f of c has to be greater than or equal to f of x for x is, for all the values of x on this interval, we would say. If we want to say it with words. X is an element of I, is what that says mathematically. We don't have to be that fancy. We just have to say for all x values on the interval, right? Okay, so it's a maximum if the value of the function there is greater than or equal to all values of the function on that interval, right? All values of x, okay? How would we change that to a minimum?
Just flip it.
Yeah, if it's less than or equal to, right? Okay, good. All right, so that's kind of our mathematical definition of an extrema, a maximum or minimum. What if this is the absolute biggest value on that interval? Now we could have a couple different pictures could arise here. We could do stuff like this. Let me draw a couple pictures to kind of help illustrate this. So let's look at like a sine function. So there is y equals sine x. And let's look at something like, how about a downward opening parabola. Okay, something like that. So is this a maximum?
Yeah.
It is, because I could define my interval to be anything on this sine function, and there's never going to be a place higher than that, right?
True.
So it is a maximum, okay? True, okay. If I take my interval to be all real numbers, this is what we would call a relative maximum. How come that's a relative maximum?
You can't
Okay,
be
there's-
sure.
Relative to the scale of the graph.
Well, okay, relative to what? What do you think? To the, well,
Each individual little.
okay, yeah, okay, relative to the points around it, it's right. It's a maximum. Agreed? Now, are there other maxima here that might be as high as that? Sure. If we look out in the distance, right? But immediately speaking, in the neighborhood of that point, so we'll just say like in there, right? It is the highest point, isn't it? Okay?
So, what's the definition of that?
That's what we call a relative maximum. It's a relative maximum because it's the highest point locally speaking. Okay? Here is a parabola. Now with this one here, this is also a maximum, isn't it?
Yeah.
Let's take that point right there. It is it a relative maximum? Why wouldn't it be a relative maximum? Okay, that's irrelevant. All we care about with the relative maximum has nothing to do with the number of them at all. It just has to do with, is it higher than its surroundings, its immediate surroundings.
Yeah.
So if we were to think about this, and it's helpful to do this, if we were to think about this kind of topographically, how would you describe a maximum then? What kind of a feature is that?
High.
It's a mountain or a hill, right?
Oh, yeah.
We might say it's a peak. Anytime you see a peak on a graph, that is, by definition, that is a
Mountain.
relative maximum. Sometimes books call that a local maximum. Local or relative, same diff, right? It just means it's a mountain, it's a peak, okay? So this is a relative maximum. Okay, but you notice something different about this case. In this case, there's only one of them, right? And therefore, there's no other place that our calculus ant could walk on the bottom terrain and ever be that high, ever anywhere in its flat world, right? In that function. So we could also say then, in addition to being a relative max,
An absolute max.
it's an absolute max.
There's no such thing as
Okay.
just a maximum.
Well, they're all maxima, but we can be a little more discerning with our.
So we were
Right.
never specific enough to say relative maximum, like when we were learning in algebra or whatever.
Right. Yeah, in algebra, you weren't very specific, exactly,
Okay,
yeah.
so now we're just-
Okay, we could even go one step further than that, and we could say, because there's no place else that this thing could ever be higher on the entire function, that is mathematically the greatest value of y, this is the biggest and baddest kind of maximum you can get is a global maximum, okay, because there's no place else it could be that. Yes, sir.
So what differentiates like an absolute and total maximum?
Say it again.
What's the difference between an absolute and
Okay, so we're gonna get there. We're gonna draw some more pictures. At this point, an absolute and a global are the same thing, okay? We haven't found an example that breaks those apart yet, okay? So let's draw another picture.
Yeah.
Okay. So what about something like this one? Let's say here is our function. It's going to be a quartic function. So it's gonna look like this. Quartic. Okay, a quartic function is a fourth degree polynomial. Going back to algebra 2, how many turning points could a quartic function have at most?
4.
No.
Two.
That's right, so 3, right?
Yeah.
Okay, how many does this one have?
3.
3. 1, 2, 3.
Oh.
So can it ever turn again?
No.
No, can't ever turn again. It goes down forever on the tails, right?
True.
Okay, so now let's say we're going to do something else here. We're going to define, we're only going to look at this on a domain that's going to be limited. We're going to go from, we'll call that A, up to, how about B right here. So on that interval, that's a closed interval because I've got the brackets, right? So on this closed interval, oh, hang on, I'm going to change one little thing, sorry. Okay, one little mistake.
You're erasing.
I am erasing.
It's harder for us to erase, usually.
Okay, there's B. There's our closed interval, right? We're going to ignore everything else. So we're only going to look on that closed interval. I want you to describe a couple things. Okay? What is this right here?
Relative.
It's a relative max.
No.
How come it's a relative max? Say it again. It's the highest point, locally speaking. In other words, it is a peak, right?
True.
Okay. What is this, by the way? We haven't talked about it, but you can extend your thinking here.
Relative minimum.
It's a valley, so it's a relative minimum. Right? Okay, so we know that every peak is a relative maximum, every valley is a relative minimum, okay? What is this point right there?
That's an higher.
That's a
Endpoint.
No, let's think about it logically.
Okay,
A slope.
what do you think that is? Okay, now,
It's an ant.
okay, on our interval, the purple interval, right, we're only focusing on the values of x within the purple region, right? What can you tell me about that point that I just made? That's what it is, okay? You got that right. But I want you to tell me why. Now we got to discuss why is that. This is an absolute maximum. Why is it an absolute maximum?
Because that's
No
what's
other
way
else
higher
is
than
higher.
that.
Right here, right here.
Nothing else is way higher than that.
Okay, on that interval, nothing else is higher, right?
Whoa.
For our interval that we've defined on that closed interval, it is
Oh,
the
I
biggest
forget.
value of the function. So that is what an absolute maximum is. Could an absolute maximum also be a relative maximum? Sure, it was right there, wasn't it? Right? If we said that our interval was all real values, which we did, right? Any value of x, then on that interval, this is the biggest point, so it's an absolute maximum, right? It's also a relative maximum. It's also a global maximum because it is the one highest mountain, the highest peak you could ever get to, right?
Yeah.
But on the other one, it's not a global.
Okay, that's right. But on this one, is that a global maximum?
No.
No, it's not. Because the function, even though we're only focusing our vision on the purple part, there are other parts that are higher mathematically, right?
True.
If we moved our vision over to the right, we would see that this point right here would become the global max,
But
right? Because that is, of all the peaks, that is the one that is the highest peak. Yes?
So if you have a global maximum, that also means it's gonna be the absolute maximum too?
Yes, a global maximum, if it's included in your interval, right, in the domain,
It implies that
then
that's
it
the
implies that it's everything. It's a
Okay.
relative max, it's an absolute max, and it's a global max, yeah.
But the absolute doesn't imply that it's the
No.
relative.
No. The absolute max, now I want you to think about this in terms of where could an absolute maximum occur? There's really only two kinds of places where an absolute maximum could occur. It could be at,
There.
well, okay, ignore the global part for a second, but
Well, it's on your
it could be a relative max, right? So an absolute max could be a peak, right? The peak might be the highest point on the interval, right? But in this case, it wasn't. How would you distinguish this point from all the other points on the interval? What's unique about it? Okay, but what about where it falls on the interval? It's an endpoint, yeah, okay? Does that make sense? By the time, where we decided to stop our interval, this ant was climbing up a hill. It just so happened that at that point, he was higher than any of the other topology in that region, right? And so an absolute max could be at a peak, aka a relative maximum, but it could also be at an endpoint, right? Yes?
So just because the the one on the left, just because it's
Just because it's a peak. Is that what you're gonna say?
The peak, it makes it a relative max.
Exactly. Because if it's a peak, think what a peak means. When you stand on a peak, aren't you standing on the highest place around, at least, maybe there's other higher mountains out there, but you're on the highest point around your vicinity, right?
Yes.
Does that make sense? So by definition, a peak is a relative max because the peak is the highest point, locally speaking, right? In that area or in that vicinity, it's the highest point. There might be other higher peaks, but those are just other relative maxima. Yep.
So the absolute minimum?
Okay.
What would that look like?
Okay, so now let's talk about the minima, right? We said that, can you define for this function, even if we didn't limit our domain, we took all real numbers, could you define a global minimum?
No.
How come?
Forever.
Because it goes down forever. So if you walk to the left or the right, every step you take, if you're on the left tail, every step you take to the left, you go lower. And there's no limit to how many steps you can take, right? Same thing opposite on the right. Makes sense? On the right, if you step to the right, you go down also. So we can't point to a single place and say that's the lowest place on this, in this universe, right? There isn't one. We can say there's a global max. We said that's a relative minimum. What is our absolute minimum for the purple interval? It is the relative minimum, isn't it?
Yeah.
Right? Because on the purple interval, that's the lowest point. Now, what would happen if I were to scoot the left boundary over? Let's say I scoot it over to here instead, right?
That is
Whoa.
the endpoint.
Okay, then we'd have a point way down here somewhere, wouldn't we?
Yeah.
At that end point, that would be the lowest point, and so that would become the
Absolutely.
absolute minimum. Okay, you got it, right? So that's our terminology, right? We've got extremum, we've got extrema, we've got relative extrema, we've got absolute extrema, we've got global extrema. It kind of sounds like a bad series of
Are we done?
albums from an 80s band or something.
How do you define global maximum?
Global maximum? Somebody answer that. How do we define global maximum? Somebody raise your hand and help us out. Right here.
The tallest point on the graph, that's also a peak.
Okay, yeah, the highest, the greatest value of the function for all the entire, all real numbers.
But it has to be a peak too, doesn't it?
It would have to be a peak, wouldn't it? Because if it weren't a peak,
Then it
then
wouldn't be high.
you could step to one side or the other and get higher, right?
Thank you.
Well, it's kind of like that graph won't have a global minimum on it, will it?
It will not.
Yeah.
You're right.
Because it doesn't peak out at
Right, exactly. Okay, yes, yeah. Okay, so then what do you think you could tell me? I want you to fill in the blanks here.
What chapter is this? 3?
Yeah, this is chapter 3. Okay, think about this for a second. So if f is a continuous, if f is continuous on the, what kind of interval is that? Closed or open?
Close.
Closed. So it includes the endpoints. On the closed interval from A to B, then f has what? Okay, well, maybe not one, but it's guaranteed to have what? Well, it's guaranteed that it's going to have, and this is just the extreme value theorem, both a minimum and a maximum, and maybe multiple, right? Okay.
What if it wasn't the closed brackets?
Then, okay, you're going to answer your own question here in a second. So let's look at some pictures, okay? Here's going to be one picture. Question?
If you have I don't know, if, this is a question, if you have like a problem where the line is just horizontal.
Mhm.
Uh,
Good question. So what if, hold that thought, we'll do that next. Yeah,
Okay.
okay. Remember, this doesn't restrict it to one, it could have more than one, right? Okay, so what about this one? Let's say this point right here, we'll call that C. Does the minimum, and by minimum here, we're talking about what? An absolute minimum, right? Does that make sense? We want to know what is, does the minimum occur, does it occur at a place where can you give me an answer? Where does the minimum occur? At A, okay. Where does the absolute maximum occur?
C.
At C, okay. What about, now we're going to look at the blue graph, different than the black graph. Now the black, or the blue graph looks like this. That's supposed to be at C. Okay, or can you tell me about the absolute extrema here? Those are supposed to be the same height. I didn't draw it. So if I ask for the absolute maximum, okay, that would be improper. It'd be absolute maxima, and they would occur at both D and B, right? Okay. Absolute minimum, C. It's supposed to be at C, right? Okay. Now here's Riley's case. Where is the absolute maximum this time?
All points throughout.
All values. Where's the absolute minimum?
All
All values, right? Okay, that's kind of a dumb one, but
Is
it's.
this like a line with a slope? Is it like no?
Okay, okay, let's take that. What if it's a line with a slope? What if we do this?
But
Where's
if
the minimum?
It's like a line with arrows. There's no.
Oh, yeah, okay, but this could be part of a line with arrows, right? But we're only looking on this interval. Okay, we're looking on the closed interval from A to B. Okay? Okay, now, how about this? Absolute maximum? C. Absolute minimum? Ooh.
So it's not a.
No, how come
Well,
you're-
it's right before it. It's a limit.
Doesn't exist, how come? Okay, so what kind of interval is this?
Open.
It's an open interval because the open interval includes only the values between the endpoints, right?
Yeah.
Okay, this is like a discussion we've had before. So A doesn't exist, right? But then why couldn't we just say, okay, well, the point next to A would be the minimum? Because there is no point next to A.
How is there not a point next to A?
Because if I said there's a point next to A,
It doesn't exist, so what?
exactly, any point that I choose that I say is next to A actually has how many points in between it and A?
Oh, many.
An infinite number, right?
But
Like,
I understand that theory, but like, you obviously do have, is your only point of the function C then?
so the only extremum, the only absolute extremum would be the maximum. There is no absolute minimum on this function,
Wait, but then wouldn't the,
right?
why couldn't it be the maximum and the minimum then if it?
Okay, it can't be the minimum, obviously, because if I say that's the minimum, I just proved you wrong, because there's a point that's lower.
Yeah, but you said those don't exist.
You're right. But those are real points on our interval, aren't they? Okay, now listen, everybody listen, stop talking, just listen, listen. So the question is, the endpoints don't exist, but there still are an infinite number of points that are greater than A and less than B. There's one right there, right? That's an example of a point with a y value that's less than f of c, right?
Yes.
So therefore f of c cannot be a minimum, because I just pointed to a value that's, a y value that's less than that, right?
Like, it's not that there isn't a minimum, it's just that if you were to say a number's a minimum, there's another one you could say after that, that's right next to it. It would
Right.
keep going on forever.
So
You
now,
could always say there's a smaller.
so far, Riley's right. So the green one right now is our best candidate for the minimum. Uh-oh, but we just shot him down. There's a pink one.
What?
And we just shot that one down because there's an orange one. And that process would never stop.
Mr. Oil,
Yeah.
can't you just
Does that make
say,
sense?
Because, okay, the question is, why couldn't we just say the minimum occurs for the value just greater than 8? Because remember, the minimum is defined by its y value, not its x value. That's the problem, you see. And so we never could, because whichever point we pick, it's like this example. Remember I gave you the example at the start of the year. I said, if I put a dot, like a really fine marker, and I put a dot of ink on the floor that is arbitrarily close to the door, and I'm gonna, every second from here to eternity, I'm just going to, at the end of time, I'm just gonna take my distance, cut it in half to the door.
okay, so like.
Would I ever be able to put a point down that I wouldn't step on?
But like,
Never could.
so say like where the hole is at 1,
Mm-hmm.
like why can't you say greater than that?
Okay, I can, but I can't define, you're right. What I could say is that the function is increasing on an interval, but I can't say that there's a maximum there because a maximum by definition has to be a point that I could point to and say that's it, right? And I can't do that.
But you can do it.
But I can do it here because here that was a closed interval, and so that endpoint is the lowest point. This time right here, all I could say, the best I could do, is say that the limit of the ant's motion to the left is that point right there, and so it's a limit, but a limit isn't good enough, right? A limit doesn't exist,
What if there
right?
was a dot above it?
If there was a dot above it, like right there,
Yeah.
well then,
No, you still wouldn't be able to.
okay, but then I just broke the rules, because the function's not continuous then, right?
And
Okay.
still would
Wait, so then is that a global maximum?
So, well, we don't know. It depends on, the best we can say right now is that it's an absolute maximum because we have limited our domain on this thing, haven't we? Right? Presumably this function, the graph of this function goes out here to the side and maybe the graph goes up like that.
You never know.
Right? And so in that case, just because we pointed the video camera at this one part of the terrain, if I panned over this way, maybe I would see a higher point. So this is not necessarily a global maximum. It might be, but it might not be.
So,
But it's an absolute maximum. Within our frame of view,
Wait,
it's
those
the
two
highest
graphs are
point.
connected?
No.
Well, they might be,
Oh.
right? Because you understand what we're doing here. When I define an interval, what we would say in math, we would say that the natural domain of a function would be all of the x values for which it exists, where we don't either divide by 0 or take an even root of a negative number, right? So if we take the natural domain, which would be the entire universe of the function, then maybe somewhere else there was a higher point, right?
Yes.
But we've artificially just kind of said, okay, we're only going to look at this from A to C. That's literally like saying, I'm going to point a video camera, I'm going to film that mountain, but I'm only going to look within the frame of view of the camera.
Yeah.
If I scoot it somewhere else, maybe there's a higher point.
Yes.
You get my point?
I see that, I just,
Okay.
if A and B don't exist, I'm not going to say that, so just continue on.
Well, no, it takes a little thought to kind of wrap your brain around this.
But
Okay,
like,
so, go ahead.
Mr. White, like, so you know how you can do like, or like this is not, like, does not relate, you know, like two lines at the
like how
same
if you were plugging
Yeah.
it,
for an answer. I don't understand why it can't be like, the minimum is greater than one.
Okay, yeah, and I can see why this is kind of a troubling thing to think about. You want to be able to say, well, we can see where the limits are. They're at A and B, right? And so there's got to be some point there because it makes sense. Because when I graph this thing, I can see where
Because an inequality isn't being specific to a number right before one. It's just
right.
saying it's greater than.
Right, exactly. And what you're thinking is, I guarantee what you're thinking is, okay, because I can graph this whole thing, and I didn't require an infinite amount of ink, right? There should be a place that's the lowest. But once again, the problem is that we're thinking about this from the perspective of one scale, right? But go back to this example. If I make a point on the ground with my infinitely thin fine Sharpie, and I'm just going to cut my distance in half to the door with every step. There's no dot I could ever make that I wouldn't step on, and yet with every step I take, I have an infinite number of dots left in front of me, right? And so therefore I can't define a place and say, okay, that's the point that's closest to the door. It doesn't exist. All I have to do is zoom in more closely, and I expose an infinite number of more points, right?
Yeah.
Right? It's a weird thing, but there is no absolute maximum on this interval, right? Because there's nothing I can point to. Okay? All right, so now, here's the next issue. I want you to tell me, so we're going to do two things. We want to be able to get to a point where we want to be able to find all of the absolute extrema on an interval. Okay? And so we know where those occur, right? You already told me. Absolute extrema occur at peaks and valleys, right? They could. Or they could occur at endpoints, right? Okay, but in order to find absolute extrema then, to find all the absolute extrema on some interval, I've got to be able to find both of those kinds of places. Endpoints are easy, right? Those x values we know. But how do we know where all the peaks and valleys are? If I don't give you a graph, what if I just give you a function? Okay, what do you think? Okay, yeah, now let's look at this. Let's look at an example of a terrain, mathematical terrain. And here's our function. It's going to do something like,
Oh.
It looks like a shark swimming in the water.
kind of, yeah. So if we're going to go from, let's say from A up to B, where are the endpoints are easy, but we got to find the peaks and the valleys. Well, what do you notice about this peak right here? It's a relative maximum, but what do you notice about the slope is 0, right? It has a horizontal tangent, doesn't it? Right? Maybe, but that's definitely one place where we need to look, right? Here's another one right there, okay? Those are places where I have horizontal tangents. Those are places where f prime of x equals 0, right? 0 slope is a horizontal line, and the derivative constitutes the slope of a function, right? So that's one kind of place we could look, but what about this guy? Okay, that doesn't have a slope there, does it?
It's not differential, or it doesn't have a limit.
Ah, well, okay, it doesn't have a derivative, right? Because derivatives don't occur where? Sharp corners, right? There's a few places they don't occur. They don't occur at breaks in the function. They don't occur at sharp corners. They don't occur at vertical tangents, right? Okay, so this is a sharp corner. So this is a place right here where f prime of x is undefined, okay? Those are both peaks though, aren't they?
Yeah.
Right, we could also get a valley down here that's a sharp valley too, which would also be a place where the derivative is undefined. And so what we're really kind of doing here now is we're saying, okay, the places where we could find relative extrema all have to do with derivatives. They either have to occur at a place where we get a horizontal tangent, which we would say is we can even describe qualitatively what kind of a peak is that? It's a, well, yeah, but what's it look like if we're looking at our flat map of our universe here? What's it look like? What kind of a peak is that? It's a smooth peak, yeah, right? So we could get smooth peaks, right, that are kind of rounded and smooth, that have horizontal tangents, or nice smooth valleys, right, that occur where we have horizontal tangents, or we could get,
Rugged.
yeah, like jagged peaks, right, sharp peaks. We might call them sharp peaks. We could get sharp peaks or sharp valleys where the derivative is undefined. Okay, but in either case, we just found out there's the trick, right? If we want to find all the relative extrema, they have to occur. That means mountains or peaks and valleys, they have to occur at those two kinds of places, don't they? Where the derivative is equal to 0 or undefined. Now, I'm going to draw you one more picture.
So all extrema have to be a derivative.
All extrema have to occur at places where the derivative is either equal to 0 or undefined. And by the way, we can group both of those. Notice this is what you learn in teacher school. Blue and red make purple. There you go. See, look at that. So those are what we call critical numbers. Those are the values of x where the derivative is either equal to 0, where we get horizontal tangents, or undefined, where we get sharp peaks, right?
But I thought you said we can't do the derivative one or the undefined one.
Well, no, we can figure out where the derivative is undefined, though, can't we?
Yes.
The derivative doesn't exist there, but we can still figure out the x values where that occurs, right?
Yeah.
Okay, now let me draw you one more picture. Seems pretty good. It's almost too good to be. It's still really good, but there's one bad part.
We only have 1 minute left.
That's fine. I can do this in 1 minute. Okay, so on the part that I've drawn there, how many horizontal tangents do you see? Well, there's one there, one there, one there, one there, one there.
6.
Okay, so 6. Now, are all of those hang on, I do the wrong thing. Oh, we'll pick it up tomorrow. Or take tomorrow off. Take 2 days off. We'll get back on Monday.
I thought you said lap day Monday.
Yeah, you're right. It is. You guys can have a lap day. I'll put this assignment up.